Okay, so in problem 10, we have another related rates problem. So it says a 20-foot ladder is leaning up against a vertical wall, which forms a right triangle between the ladder, the wall, and the ground. So basically, if you imagine what it looks like, so they say this is the ground, this is the wall, and you have a ladder leaning against it. Okay, so this is the right triangle that the problem is referring to. So let's label some variables, right? So let's say the ground is x, the wall is y, and the ladder is z. So then, because it forms a right triangle, you have the equation x squared plus y squared equals z squared from the Pythagorean theorem. Okay, so it says the top of the ladder is 16 feet off of the ground when it slips straight down at the wall at a rate of 4 feet per second. So how fast is the base of the ladder sliding on the ground at this moment? Okay, so let's identify some variables, right? So the ladder is 20 feet, so that's z. It says the top of the ladder is 16 feet off the ground, so that's referring to this distance here, so y is 16. And then it slips down at a rate of 4 feet per second. So that's this like going down like this, so that's 4 feet per second. So that's how y is changing. And because the ladder is going down, y is decreasing. So that means that dy dt is equal to negative 4 feet per second. Okay, so what else do we know? Well, the ladder doesn't change, so that means that dz dt has to be equal to 0, right? Because there's no rate of change. And then we don't know what x is, but we can calculate x using the Pythagorean theorem, right? So x squared plus y, which is 16 squared, is equal to z squared. So z is 20. So I can calculate this, right? So x squared is 400 minus 16 squared, which is 256. So x would be the square root of, so 400 minus 256 is 144, and square root of 144 is 12. Okay, so x is 12. And what are we trying to find? How fast is the base of the ladder sliding on the ground? Right, so the bottom ladder is going this way. So that's going to be dx dt. Okay, so that's the setup for the problem. And then now we're ready to calculate. So we do implicit differentiation to every variable, right? So the derivative of x squared would be 2x, but then we times dx dt. The derivative of y squared would be 2y, but then we times dy dt. And then the derivative of z squared would be 2z, and then times dz dt. Okay, so now let's just plug in all the numbers. Right, so x was 12. Dx dt is what we're trying to calculate. Y was 16. Dy dt was negative 4. And then z was 20. But dz dt was 0. Okay, so this whole thing is 0. Okay, so now what do we have? 24 times dx dt minus 2 times 16 is 32. 32 times 4 is 128. So you have minus 128 equals 0. Okay, so now we can just solve. So 24 times dx dt is equal to 128. And then so dx dt is 128 over 24. So what is 128 over 24? So let's just calculate that. And it comes out to be 5.33. And the units are in feet per second. Okay, so that's problem 10.